These are three common mistakes that students make about the normal force. Number one, they think that the normal force always points up. This is wrong. Why? Because the normal force, by definition, points perpendicular to the surface that you're on. So in this example, the surface is flat and the normal force is indeed pointing up. But what happens if I tilt the surface and now I place a book on my surface? Well, now the surface is this way, and so perpendicular is going to point in that direction. So it's going to make 90 degrees with the surface. What happens if I have a wall and I place a book on the wall? Now I push the book onto the wall. That produces a normal force, which is again perpendicular to the surface. So notice the normal force always is perpendicular to the surface. It's not always pointing up. Number two, common mistake is that students think that the normal force always balances the weight. That's not always true. It is true in this case, the normal force does balance the weight. But here's an example where that's not true, because here the weight points down and the normal force is in some angle, in which case the normal force only balances part of the weight, which is mg cosine theta. So you can see the normal force is actually smaller than the weight in this example. What happens here? Well, here the normal force has nothing to do with the weight at all. In fact, it only depends on how much I'm pushing the book onto the wall. If I'm not pushing the book onto the wall, then there is no normal force. So here the normal force is equal to how much force I am pushing with on the book. So this is not right. Let's see mistake number three. Mistake number three is that students tend to think that the normal force and the weight on an object are Newton's third law pairs. Let's see why that's wrong. Consider a book lying on a table. We know that the table exerts a normal force upward on the book. What is the reaction to this force? Well, all I have to do is flip the two subjects at hand. So instead of table on book, all I have to do is say book on table, and that produces a force on the table that is equal and opposite to the force by the table on the book. So in fact, the Newton's third law pair to the normal force is yet another normal force, this time on a different subject in this problem.